Let's start with the remaining types of vectors. So the next being anti-parallel vectors. Anti-parallel vectors. So when we say anti-parallel vectors, we can say these vectors which have opposite direction are called as anti-parallel vectors. So we can read the definition as vectors which have opposite direction, which have opposite direction are called as anti-parallel vectors. And a key note is that angle between these vectors is 180 degrees. So what I say is that, so let me draw an example. For that, let me change the color of the ink just to a bright color. Yeah, so what I mean is that if I have two vectors like this which are opposite to each other, so let's name this as vector B, as this as vector A, we can clearly see that angle is a straight angle, so the angle is 180 degree, and these are opposite in direction. So if I define a sign convention, so if I take this to my right side as positive and left side as negative, I can say that A is in the positive direction and B is in the negative direction. So these vectors are in opposite direction. So moving on to next type of vectors called as negative vectors. Negative vectors. So as the name suggests, so these vectors have equal magnitude but opposite direction. These are similar to uh, anti-parallel vectors, or sometimes these are same. In fact, they're same. So we can write the definition as vectors vectors which have equal magnitude which have equal magnitude but opposite in direction. So let me draw that. So let me change the pen color for that. Okay, so uh, when I said these are similar to anti-parallel vectors, what I meant was the direction is same, but they're not completely same, as they should be parallel. Usually these kinds of vectors are parallel to each other. So if this is a B, this is A, so a key point is that parallel, they should be parallel. So we can write this as vector AB is equals to minus BA vector. This is clearly, we can understand it from the diagram, that when we multiply vector A and B, which is the same as in the previous page, as I defined that uh, my right side would be positive and my left side would be negative. So I can say that B is in the negative direction, so I can write the direction as minus B A vector together. So I think so negative vectors and anti-parallel vectors have some difference, but they are nearly same. So moving on to next type of vectors called as co-initial vectors. Co-initial vectors. So when we say co-initial vectors, So these are those vectors which have the same initial point. So we can say that vectors having same initial point, same initial point. So when I draw a diagram, this might become a bit clear. So what I mean is that, so if I take a point O, and if there are multiple vectors originating from it, we can see there are three vectors. So let me name that A, B, B, and this is vector C. So they have a common point, they have a common point, they have a common point. So when they have a common point, we can say all such vectors as co-initial vectors. So moving on to the next type of vectors called as collinear vectors. The previous one was co-initial, this is collinear. Collinear vectors. So when I say collinear vectors, so we can say these vectors are lying in the same line. Vectors lying in the same line can be said as collinear vectors. So let me write the definition. Vectors lying in the same line, are called as collinear vectors. And an important point is that the angle between any two such vectors is either 0 or 180 degrees. So the angle between any two collinear vectors can be 0 or 180 degrees. So let me draw a clean diagram. So uh, this is vector A. So let me represent vector B with another color. Okay. So this is vector B. So when we say that they're lying in the same line, so if I consider this as a line, we can clearly see that both vector A and B are lying in the same line, and the angle between them is 0. For now it's 0. If the vector B separates from vector A, the angle then is formed 180 degrees. So there are two cases. For the angle in a collinear vectors, that is 0 or either 180 degrees. So moving on to another type of vectors. Now these vectors are called as coplanar vectors. So when I say coplanar vectors, all those vectors which lie in the same plane are called as coplanar vectors. So the definition is all those vectors lying in the same plane are called as coplanar vectors. So let me draw a diagram for that. So if we consider this as a coordinate axis, so let me name the coordinate axis. So this is my x-axis, so this is my x dash axis, so this is my y-axis, this is my y dash axis. So I can name it as, I can take the names as per my wish. So it does not actually matter which direction is x and y. So let me change the color to black. Yeah. So if this is one vector and this is one vector and this is one vector, this is one vector, so we can clearly see there are many vectors in the xy plane. So in this plane there are many vectors, so we can see that all these vectors lie in the first quadrant, in or the first quadrant plane. So we can say that all such vectors as coplanar vectors. So if I have vectors like this, we can also take the direction as per our wish. Like, the direction actually does not matter here. The only thing which matters is on which plane all those vectors actually lie, the first, the second, or the third, or fourth in this case. The the direction does not change or define the coplanar vectors. The or the thing which defines the coplanar vectors is on the plane they're lying in. So moving on to the next type of vectors called as concurrent vectors. So when I say concurrent vectors, so concurrent vectors. So when I say concurrent vectors, so I can say all those vectors which pass through a common point. So all those vectors which have a common point are called as concurrent vectors. So we can define that as all those vectors, all those vectors which have a common point is called as concurrent vectors. So let me change the color. Yeah. Now let me take this as vector b and this as vector a and this as vector c. So imagine there's a point. So let me change the color again. So if I extend all of these points, we can see that they all lie in a one common point. So they all have one common point, one common point, or they originate. So let me change the color. They originate from one common point. As we can clearly see that all of the three vectors have the same common point when I extend their tail, as it is called as. So moving on to next types, or the next type of vector, that is called as null or zero vector. So when I say null or zero vectors, so what I mean is that all those vectors, so they are defined as vectors having zero magnitude. They're usually defined as all those vectors having zero magnitude. So null or zero vectors is all those vectors with zero magnitude. So there might a question which will arise in our mind, that why do we actually need null vectors even if like they have zero value. So what is the use of these vectors? So these vectors are used to determine the direction, or like these vectors are like used to uh, like yeah, like used to detect the direction, for example. And 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 some of these null vectors is usually zero. So what happens is that I have a vector, but I don't know, like, so which direction it's going. And so if I want to know the direction, so I can use a null vector. Or if I want to perform addition or subtraction of a vector which actually helps me in solving, I can use a null vector, not only direction. So the main use is that I can add two vectors. For example, if I add two vectors and if I get an answer, so I can use this null vector for that. So I can say that sum of all null vectors is 0. So if I add 0 plus 0 plus infinity times, or let me not take that, 0 plus 0, that equals to 0. So addition of all the null vectors gives me 0. So moving on to another type of vector called as unit vector. uh, the name might have put some thought, that unit vector. So we can generally say, or we can say, that any vector which has unit magnitude is called as a unit vector. So let me write that: any vector having unit magnitude is called as unit vector. Okay, so uh, why do we use this vector? So it is also used to specify the direction in pretty much all the cases. So it is used to specify the direction, so it is one of the use. And it is represented by a special type of symbol called as cap. So I can, if I have a vector, I can write it as a cap or hat. So I can represent it by represented by cap or hat in some places, as it is called. So this is how it is represented. And one of the use case of this is specify direction. Specify direction. Specify direction. So moving on, let's solve some questions which will give us a clear idea. So question 1, so we need to find the angle between I'll draw the diagram. So let me clear the screen. Okay, so question 1, find the angle between A cap and C cap. So let me draw the diagram. So this is my vector B, this is my vector A, and this is my vector C. Don't get confused, I can also represent it a cap as C, as both C and A are unit vectors, so I can also write them as cap. So go ahead, pause the video for a minute or two and solve this question. Give a try. So what I can do is that in the previous video we have studied the loss of vectors. So what I can do is that I can shift this vector C to the base out here. So vector C can be shifted, and I know that this is 30 degree, so and this is 90 degree. So what I can do is I can add 90 plus 30 to give me the complete angle. So if this is vector A, so the complete angle out here will give me the total angle between A and C, so which is 120 degree. So moving on to another question. Okay, the another question is, a regular hexagon is shown. Find angle between. So the first question is between vector A and B. The second question is A and C. So let me draw that. Let me draw a regular hexagon. Or let me draw a clean diagram. Yeah, so this is vector A, this is vector B, vector C, vector D, this is vector E, and this is vector F. So the direction is like this. So we need to find angle between A and B. So the answer, so let me change the color for the solution. Okay, so this is the diagram. This is vector A and this is vector B. So if I extend this, I know this is 180 degree, so this is something minus 180. And if we know that the exterior angle of a hexagon, it is 60 degree, so I can calculate it as 180 minus 60, which gives me 120 degree. Or if we know that an internal angle of an hexagon is actually 120 degree, so I can, if I know the, so if I have the knowledge of a hexagon, so I can directly write the answer as 120 degree. So moving on to question B, it says that angle between A and C